All right, so here's a fascinating one, cyclobutadiene as a ligand. If you know anything about cyclobutadiene, you know it's incredibly unstable. It's anti-aromatic. It violates Huckel's rule, right? Because Huckel's rule says that only aromatic, the only aromatic planar systems are those with 4n plus 2 electrons, where n is an integer. So the first one is n equals 1, which gives you 4 times 1 plus 2 is 6, which is benzene, right? So cyclobutadiene's anti-aromatic, it can't be isolated without doing some weird tricks, okay, by itself at least. But if you add 2 electrons to it, now you have an aromatic system. And so you can look at the MO diagram of this, and now you can actually stabilize it with a metal center. So these are the 3 highest occupied molecular orbitals. You can see the 3 sets of orbitals there with the 6 electrons in them, and then the LUMO, the pi LUMO. And the symmetry works out such that you get sigma donation with this lower one, and then pi donation with these 2, okay? In theory, again, just like butadiene we talked about in the last video, you can have delta back bonding, but this 4 pi ends up being too high in energy, so you don't see that. Regardless, you can have these stabilizing forces, okay, these stabilizing bonding interactions, these donations, in order to make stable complexes. So what's interesting is that with butadiene, we saw in the last video that it affects the different bonds of butadiene differently. So you have some contraction of some bonds and lengthening of other bonds. Here, if you look at it carefully, right, no matter, even if you have less or more sigma pi donation, sigma or pi donation, everything is, all 4 carbons are affected equally. So, you know, if you were to increase or decrease this donation, well, that's just increasing or decreasing bonding on all 4. So yeah, maybe you decrease and increase the bond lengths, but you're going to decrease and increase all the bond lengths equally. And with these are degenerate, right? So if you increase pi donation, let's say, well, you're going to increase bonding interactions here and here between this carbon and this carbon and this carbon and this carbon, but there's anti-bonding interactions here and here. But wherever there are anti-bonding interactions here, there's bonding interactions there, and this degenerate MO, and vice versa. Okay, so these sort of work together, these degenerate MOs work together to affect all 4 carbons equally. So every time you see a metal cyclobutadiene complex, you'll have a perfect square geometry, okay? And because cyclobutadiene is so reactive, you have to make this in situ. So here's one way you can make it. You take like a dichloro complex with just with only one of the alkenes, right? And then you do a double dehalogenation, and what happens then is that's going to give you a double bond here, okay? And then in situ, you're making cyclobutadiene, which then can coordinate to a metal if you have that present. So you heat this up or something like that. All right, so that's cyclobutadiene.